Yo, Brainiacs, welcome to the Johnson Kendrill video hour, but Johnson flying solo today, so no Kendrill for today. We're going to spend two separate lessons in 8.6, 2 days in 8.6, and today we're doing the part 1, which is solving rational equations. So a little different from what we have been working on today, and maybe you want to note that this is part 1 of a 2-day lesson. So equations are definitely different from the expressions that we've been working with because there is an equal sign. And as soon as we add an equal sign, we have a little bit more flexibility in how we manipulate the equations. And what I mean by that is we no longer will have to work in useful forms of 1. In my opinion, that makes things a little bit easier because when we add an equal sign, we can do whatever we want to one side as long as we do it to another. So then we can have some different options for solving. I think I'm going to uncover these steps for you. If you want to just hit pause and copy those down, I will leave those up for just a second, and then I will get going on the example. Okay, so this is an equation. That's the first thing I'm going to note is that it is an equation. So I have, again, the ability to do whatever I want to one side that as long as I do it to the other. So step 1 there says factor the denominators to find the least common multiple and maybe simplify the fraction. So I'm going to start with that. In the first fraction, I see the denominator is x minus 3, and I believe that's as good as that gets. The second one is x plus 3, that is also a simplified factor. And then in the other side of the equal sign there, that is a difference of squares. That's going to factor into x plus 3, x minus 3. So the factoring doesn't necessarily help me cancel anything out here because all those numerators are just single terms, but that's not wasted effort because it's going to help us find the least common multiple anyway. So step 2 says if it's a proportion, meaning no addition or subtraction outside of the fraction, then we can just cross multiply. That's not available for us here because we have a plus sign on one side of our equation there. So now we're on to the most important step, which is to clear the fraction, and we are allowed to do that as long as we multiply by the least common multiple on both sides. So the least common multiple of this expression is, or those denominators I should say, is x plus 3, x minus 3. So I'm going to multiply by that on both sides. And again, I don't have to do it as a useful form of 1 because we are doing it to both sides. So what we have to do is go through each individual term. So I'm going to apply that to all 3 terms that I see in this thing. Some things will cancel and some things will be remaining. So I'll show you, like in the first fraction I have, I'm just going to do some side work here, x over x minus 3, and what I'm doing is multiplying that by x plus 3, x minus 3. So some stuff will cancel. Those x minus 3s are going to go away, and then I will be left with the x times x plus 3. That's what I'm going to write down. Now, if I was teaching this in class, I would just use my hands to cover up those factors. So the x minus 3s cancel. I'm left with x and x plus 3. So I'm going to repeat that process. Now I'm looking in the second fraction. The x plus 3 is what's going to cancel out this time and write down whatever is remaining. So in the original numerator, I had an x, and then what's left from the factor that I'm multiplying by, this time it's the x minus 3 that is remaining. So lastly, I'm going to look on the other side of the equal sign there. Actually, both factors in the denominator cancel. So all that I'm left with in the numerator there is the 2. So see how that least common multiple can be really helpful in clearing your fraction because now we have no denominators whatsoever. So we've taken care of that really important step. Now we're on the simplify and solve. So first I want to get rid of these parentheses. That would be x squared plus 3x. This guy is going to become x squared minus 3x. I'm going to combine like terms. The 3x's will cancel. So 2x squared equals 2. And then I'll solve that. That is a quadratic equation, so we might have to use some quadratic solving ideas today. This is just an x squared and a number, so I'm going to divide by 2. I get x squared equals 1, and I'll finish that out with a square root. There are 2 solutions to that, positive and negative 1. Alright, so I've scribbled all over this darn thing. So I'm going to go back and get rid of some of this writing so that we can talk about the check. the last step that we have to do is check to see if either of those answers, positive and negative 1, would make an extraneous solution. So remember, I'm looking here to see if that would make a divide by 0, here or here, and I don't think that's going to be a problem in any of those denominators. So that means that x plus 1, x minus 1, x equals plus and minus 1 is our final answer. Here's a second example here. We want to start with those steps that I listed up above, which the first one said factor, and see if you can simplify. And this is an example where it really will be helpful for us to do that. That factors into x plus 3, x minus 1 in the denominator. And that is helpful because now I have an entire factor that is in common. So that's going to go away. So let me rewrite what the problem becomes after we do that. That's going to be a huge time saver. 1 over x plus 3 equals x over 4. Looking at step 2 from our list there, this is a proportion. It's a fraction equal to a fraction. So I'm going to use the cross-multiplying idea to solve this. 1 times 4 gives me 4. And then on the other side, I would have x times x plus 3, which will be x squared plus 3x. This is a quadratic again. So again, we're going to have to use some quadratic solving ideas from previous lessons. This time, though, it's x squared, and I also have the x term. So I will want this in standard form. I'm going to move that 4 to the other side, so I get equal to 0. And you have some choices at this point. You can factor or use quadratic formula. You know me, my choice is always factoring if possible. I think that's a little faster. So x plus 4, x minus 1 are the factors. And then we go from factors to solutions by setting those equal to 0. X equals negative 4. That's what we get for the first one. And then set this guy equal to 0. X equals positive 1. Those we think are the solutions, but we want to go back and check to make sure that neither of those make an extraneous solution. When you do this, it's very important that you look at your unsimplified version of your equation. And because of that, if we were to substitute a 1 there, 1 minus 1 would be 0. That's a problem. That's going to make a... Oops, sorry, I got interrupted there, so I'm not sure exactly what I said last. It does make a divide by 0 when we substitute the 1 in the denominator, and for that reason, 1 is an extraneous solution. It is not actually a solution in this equation. That means x equals negative 4 is the only solution. All right, excuse me. One more example here. I'll give you a second to write that down. It is not a proportion because we have a plus sign between two of those fractions. So we are not going to be able to cross multiply here. Step 1 is factor, see if you can simplify. I don't think that's going to help us here. It's also not a proportion. We've taken care of that. So we are on to the point where we are going to find the least common multiple and multiply by that on both sides of the equal sign. The least common multiple is x plus 1, x plus 4, because those denominators do not share any factors. So again, what's coming next? We're going to multiply that to every single term. Some things will cancel and some things will remain. So looking at the first one, the x plus 1 will cancel out with the x plus 1 we're multiplying by. We're left with the x from the numerator and then the factor of x plus 4. Now I'm going to move to the second factor. This time the x plus 4 cancels out. I'm left with the 3 from the numerator. Notice I put plus 3 there. That's because there was a plus sign between. If there was a minus, you would want to do a minus. And then the polynomial factor left is x plus 1. On the other side, the x plus 4 is going to cancel, and we're left with x plus 3. Oh, and the x plus 1. Oops. Almost forgot. So this looks pretty intimidating right now, but just start simplifying. I'm going to distribute x squared plus 4x. Distribute 3x plus 3. On the other side, I'll have to FOIL x squared, 1x, 3x, and a 3. And then I'm going to combine some like terms, see if we can't simplify this down a little bit. On this side, I have a 7x I can write in the middle. And then on the other side, that will be a 4x in the middle. And if I start rearranging this, it looks like these are quadratic, but I actually have an x squared on both sides. If I try to get those together, they're actually both going to cancel, which is awesome. So now that means I don't have a quadratic equation. I actually have a linear equation that we're working with. Same idea, so I want to get my x's on the same side. That's going to leave me with 3x plus 3 equals 3. I'm going to subtract 3 to isolate the x. And I actually get 3x equals 0, divide by 3, x is equal to 0. So we have one solution here because that ended up being a linear equation. I want to do a quick check. X equals 0 is my answer as of right now. I'm going to scroll back up so we can look at our original problem. I want to make sure that doesn't make any divide by zeros. And the only way that that would is if we had just a plain factor of x in a denominator. That's not going to be a problem here. So x equals 0 is the solution, and it does check. Alrighty, that's it for part 1. We're going to get some practice on that before we move on to word problems. That's all for now.